In this video, we are going to see about shear force and bending moment diagram for a simply supported beam of length 8 meter and carrying a uniformly distributed load of 10 kilonewton over a distance of 4 meter. Okay. First, calculate the reaction forces Ra and Rb. Taking the moment of the force about A, we get in clockwise we are going to get plus sign, anti-clockwise we are getting plus sign, and in clockwise we are getting minus sign. Rb, we are taking moment at Ra, Rb into 8 equal to 10 into 4, that is uniformly distributed force into 1, that is 1 meter, it is away from Ra, so 1 plus the midpoint uniformly distributed force act only at the midpoint, so 4 divided by 2 bracket equal to 120. Then Rb is equal to 120 by 8, 15 k Newton. Then Ra is equal to total load on beam minus Rb. Total load on beam is equal to total load means the uniformly distributed load minus 15. So uniformly distributed 10 into 4, we have to multiply 10 kilonewton per meter into 4 minus 15 is equal to 25 kilonewton. Ra is equal to 25 kilonewton. Then we are going to draw shear force diagram. Shear force diagram is a very easy diagram. First you have to concentrate on Ra. From Ra we have to draw the shear force diagram. Ra is the most important point. Ra. At Ra, 25 plus 25 the upward direction. Ra reaction force acts in the upward direction, so draw Ra 25 kilonewton upward, and no force acts up to C level. There's no force acts, so draw a straight line. After that, uniformly distributed load acts in an inclined line, so you draw an inclined line. Then after inclined line, then draw a straight line, since there is no force acting up to the end B, so I have to draw this line. After that, draw a straight line 15 meters, since the RB acts upward. So this line, we have to draw the line, then we have to find out the values. But end values we can easily find out, 25 and 15. The Ra is equal to 25. The shear force at A is equal to 25 k Newton, as the reaction force acts upward. The shear force at C starts acting downward. So we have to write the equation: shear force CD up to CD equal to plus 25 minus 10 x minus 1, taking from the end A. So we are putting minus 1. Yes, we are taking it from end A up to A. From A is 1 meter. Then put 5 meter. So put x equal to 5 meter. The shear force at D is equal to plus 25 minus 10 into 5 minus 1. So you get minus 15 kilonewton. This is a calculation. We can do it on your own. After that, we are finding the reaction force, the shear force, that is the shear force at D. As the reaction Rb goes upward, and after point, as the reaction Rb goes upward, after point, you can get it clear now. As the reaction Rb goes upward, after D point no force acts. So it goes straight line, as like this. It goes straight line like this. It will go straight line. So 15 kilonewton, Rb is equal to 50 kilonewton, goes to the neutral line. In this, how to check that whether you have drawn a correct shear force diagram or not? You can find it on your own. How much area it covers. If you draw with a scale, if we draw with the scaling method, then how much positive surface is covered is equal to how much negative surface covered. So both will be equal. The surface area will be equal. We can calculate on it your own to check whether the shear force diagram is right or wrong. To find where the shear force is equal to 0, that is E point where the shear force is equal to 0, put shear force equal to 0 in the equation. In the equation, let's equation, shear force C minus D plus 25 minus 10. Put shear force equal to 0 here. Put shear force equal to 0 plus 25 minus 10 x minus 1. Then we get the equation 0 is equal to plus 25 minus 10 x minus 1. We get x equal to 3.5 meter. This is the distance. This is the 3.5 meter distance where the shear force acts, where the shear force is 0. Then we are going to draw bending moment diagram. Bending moment diagram will be like this. First, the bending moment at both the end of simply supported beam is equal to 0. Bending moment is 0. Then we have to draw bending moment at A. Bending moment at A is 0. Bending moment at also B is also 0. Bending moment at C is equal to RA into 1. RA is what? 25 into 1. This is the bending moment. Since it is clockwise, acting in the clockwise direction, it is plus 25 plus Newton, plus 25 kilonewton meter. Then bending moment C bar D equal to RA into X, that is, it is in the clockwise direction, RA into X. The uniformly distributed load UDL, it is in the anti-clockwise direction. 10 into x minus 1 divided by 2. So we are taking from the at point A, so we are using x minus 1 because 1 meter is away from A, so we are taking 1. So 10 is the kilo UDL and is the distance, how much it is how long it act, and is the midpoint of the distance. Then after solving the equation, we get put x equal to 1 to find bending moment at C. Bending moment at C is equal to 25 kilonewton. We can easily find out. Put x equal to 1, this will get 0. So here is 1, 0 to 25 kilonewton. Put x equal to 3.5 where the bending moment is maximum. You have to see that the bending moment will be maximum where the shear force is 0. So 3.5. You are substituting this in 3.5 in the equation. So get 25 into 3.5 minus 10 into 3.5 minus 1 whole square by 2 at 56 2.5 kilonewton. So 56 2.5 kilonewton is the maximum length. We have to draw the parabolic curve for this UDL and a straight line for this no load. Straight line like that it will come. And 45 we can easily find out. Put 5 in the 5 in the 50th direction. 25 into 5. It will get 125. Like that we can calculate and we can find 45 very easily. The bending moment at D. So the bending moment comes to 0. After all it comes to 0. So now we are comparing the bending moment and shear force diagram. The bending moment and shear force diagram, that is 20 RA is equal to 0. When bending moment is somewhat maximum, bending moment is somewhat maximum like this, 56.25, that shear force is equal to 0. So you can easily find out whether your bending moment diagram is correct or not. This is the way how to draw the bending moment, and I'll try my level best to get you uniformly varying load and another question in another sum in another video. Please subscribe my channel and like my videos. Thank you.